Welcome to another presentation on scripting basics, this time for Linux operating systems. Right. So, first thing that you may be asking yourself is, what is a script? Right. Well, a script is just a file of executable commands. So if you want to make a file that does multiple things, one right after the other, without you having to do anything other than call the file, that is where you want to use a script. All right. Kind of arguable if you're in the world of programming, thinking about like a subroutine or something, something that you run over and over again. So maybe you run this multiple times a day to pull information in or whatever the case is. All right. Anyway, a script is just a file of executable commands. All right. This is going to be stored in a text format. So it's just characters. All right. Nothing special here. No format other than maybe using tabs or something like that. You have access to all of the commands of the shell, including logic. All right. So if you want to do, if statements and things like that, which we'll come back to in a little bit. And where shell scripts to me really shine are for automation. If there is something that you want to do over and over again, you don't want to have to do it by yourself, manually type all the commands in or open files and view them or whatever the case is. That is where scripting comes in like huge. It's automating your tasks for you. So if you have something that you need, like I need to do this every morning when I get to work, you could set up a script that just runs by default when you log into your computer or at 2 a.m. or 5 a.m. or whatever the case is. So that way that data is automatically there for you. As long as the data you're accessing isn't changing, and by changing I mean like the format isn't changing, that script will just grab the information, process it, do what you want with it. Now, if at some point they change the form and it changes however you find something in that, well, then you're gonna have a bit of a harder time. But otherwise, scripting is a wonderful thing. All right. So to run a script, we would normally do sh file name. So in this case, I have a file called scripts. Boom. And open scripts. That's right. It's .sh. There we go. Hello world. All right. So nothing too crazy going on there. You also could do bash, same thing, scripts.sh. Does the exact same thing. All right. And this is just which interpreter are you using. Are you using the sh interpreter or using the bash interpreter? All right. There are benefits to the bash interpreter. There's more commands that it has access to and things like that. But maybe there's other benefits to the sh. So it really comes down to what you need to do. Right? So you do need to pick the interpreter that's right for you when you're running these things. And again, we'll come back to that in a minute. Okay. So we can run it that way. Now, there are also another way to run it, and that is just to do /scripts.sh. All right, but now you're noticing that right now that's telling me permission denied. Right? And that is because that file is not currently marked as executable. So if I would do ls-l to list the capabilities of that file, what we can do, you'll notice that my scripts file right here has read write for user, read write for group, and just read for everybody else. All right, so a little bit of give and take going on there. Now, if you want to run it that way, then we would need to do it is change mod plus x, so add executables to the scripts.sh file. All right, and again, if I run that ls-l, you'll now see that it's green, telling you that's already executable. But you can see that we added as executable for user, for group, and for everybody else. So everybody can now execute this file. So now if we would do that // it is scripts, boom, it works just fine. All right. So you got to be kind of careful there and figure out which way you want to execute things. So just kind of something to keep in the back of your mind. And I told you I was going to come back to the interpreter. All right. So if we look at my scripts file here, all right, you can see that right now at the top I have pound !/bins/bash. All right. So that is saying that if we run this as an executable, just doing that /file name, it is going to use the interpreter of bash. All right. So this is the location of that. If I had this as just as sh, then it would use the sh interpreter. All right, so you got to make sure that if you want to run this as purely an executable file, to make sure you have those, that first line of your code having the interpreter information in it. All right, and that's the location of the interpreter, which is bin / whatever the interpreter is that we're using. So make sure you do that. Again, depending on what you're trying to do, you'll need the different interpreters. For most likely for your final assignment in this class, the shell script one, you will need to use bash, but depending on how you solve some of the problems, it isn't going to be necessary. So it's just something that you need to think about of which way do I want to handle this. So I'm just going to set this back to bash. So those types of things. Now, for editing files. You can edit it however you like, whatever program you want. Or if you want to use Vim, if you want to use Nano, if you want to use some other text editor, all of those are perfectly fine. All right. The book talks about using Nano, and I was just in Nano. Go back there. All right. Nano is actually probably my favorite editor of all of them. All right. It's to me just the simplest one. Right at the bottom, it tells you some of the shortcut keys that you might be using. All right. Up on the screen on the left-hand side here, I've got other ones. So if you want to exit, Control X, and then you would do yes to save if you edit it. You just have Control O to save it. So anyway, I really like these. You can take a picture of these, come back to this presentation at some point to look at these. All the shortcut keys for Nano, or just look them up on the internet. But I like Nano for editing. I think it's a simple text editor that is easy for you to use and understand. Okay. Now, let's get back into scripting basics. Okay. So one of the things that you probably want to use often is variables. All right. One of the reasons you like to do scripts is to automate things, and those things might change slightly. Maybe you want to have the date file in your log file, or you need input from the user, or whatever the case is. Variables are a super helpful thing in that aspect. Now, unlike many other programming languages, you don't have to identify what your variables are or classify them. All right. So let's go ahead and do nano, variable.sh. Boom. All right, we're into a new file here. We're using nano, as I said before. So to set a variable equal to something, you just do your variable name. So in this case, it's animal equal to penguin. All right, no spaces in there. All right, so now if I echo, and my PowerPoint is wrong here, it should say echo $animal. Right, it will make your life a little bit easier. All right, not easier, but anyway, it'll output that. I don't know where I was going with the other one. And also notice that the color coding here, because we said this is an SH file, it's using that to say, okay, we should be color coding things slightly for you. So to make your life a little bit easier. All right. So that is definitely helpful in the long run, in my opinion. So now if we exit out of this, even though I told it to echo animal, when I run this, so sh variable, notice that it outputs penguin. It's to you because I can't spell, but that's okay. And again, we could make animal equal whatever we want. We can make it equal to horse. Control X, Y to save, enter, run it, and boom, now it outputs horse. All right. So we can do that. All right. Now, if you want to set a variable equal to a command that you want to run, all right, and again, my PowerPoint is ever so slightly wrong here, and I think you all can understand why. All right. We would say, let's go ahead and delete all this. All right. So I'm going to say current date. Oh, extra R in there. Current date equals, and I always think it's a single quote. All right, it's not a single quote. It's the one just to the left of the number 1 on the keyboard. All right, or the one that has the tilde on it right above tab. All right, it's that single. Looks like a single quote, but it's not quite one. All right, so you do that, and then you would type the command in. So date. All right, and now again I could echo that. So echo current date. Boom. Oh, now it's saying current date. If you were on top of your game, you notice what I did wrong. I missed the $. Try that again. Boom, there we go. So now we have the current date. So if I had a text file or whatever, not a text file, a log file, and I wanted to make sure my date was in there every time I ran this, this is a great way to do it. Or again, if you wanted to save your file as something with a date, this would be a great way to do that as well. So that being able to run commands inside of, and save that output to a variable to then process, wonderful. Yes, you could pipe it there as well, depending on what you're trying to do. So there are multiple options for this. All right. So let's go back in here. All right. So right now we put the current date is. All right. Let's say this is some form that's going to get submitted to whoever it is. All right. So we do current date, and then we echo that, and we say echo what is your name. Right. And now we want the user to input something. All right. And we could use the read command for that. So you would do read. I would go with first name. I didn't ask for first name, but just what is your name? All right. And we could say, echo is your last name. Oh, pretty good measure here. And we could say read name. Then we could echo your name is, we would do $first name, case $sign last. Right, and now if we run this, puts the date out there. What's your name? Greg. What's my last name? Betts. Boom. Oh, and it doesn't like that. I think I always miss something. Yep, missed a single quotes on there. Greg Betts. All right, so your name is Greg Betts. I'm not perfect, all right? Very few people I know are perfect when they're writing code, and that's really what we're doing here. We are writing code. Now, it's a shell script. It's not a traditional coding language. I mean, yeah, it is, but it's not something that you normally would think about coding in, but it's definitely something that you want to kind of keep in the back of your mind. All right, so we can get information with that. Now, you also can get information passed into this, all right? So instead of, let's come in here. So instead of me asking for your first name and your last name, so we can just delete all this. All right. So instead of first name and last name, I could put a 1 and a 0 here. All right. And these are the, 1 and 2. These are the arguments that we're going to pass in. So now when I would run this, I would then type in Greg Betts. And now it says your name is Greg Betts. All right. So it's now getting that information as arguments that we're passing in when we call this thing. So it depends. Do you want to prompt you, or do you want to just be able to type them in when you type them in, when you call the command? So definitely, something that you can use, very useful for certain aspects of things. All right. And the other thing is $0. Okay. This, right? That is the name of the file. So it says variable.sh, and that's the file we're using. So again, you can very easily have it output something so you know where the data came from. So you're going, oh, that's came from my variable.sh file. Print the working directory, then print the file name, put it all together, boom. You got yourself a very nice way to track logs of what's putting information into that log or something along those lines. All right, now we're getting into the really interesting things here, and that would be if statements, right? Now, I believe I have I do, so let's go ahead and do nano if. All right, and I have a little if statement here. So I'm going to read the input, and I'm going to echo it just so I can see it. Okay. And then I say if the input, $sign input, so again, the variable input, is greater than or equal to 1, then echo yay. All right, and the key here with ifs is you have to have a fee. So if is saying this is where the if statement begins, and fee is where it ends. All right. Fee is just if backwards. That's where fee came from. All right. So I can exit out of this right now. All right. So I can sh if. It's I didn't tell it to prompt me, but I know it is. So if I'd say 5, it'll say yay. All right. If I do 0, it's not going to give me anything. All right. Just spits it out. Doesn't tell me yay. All right. Now we can add more to this. All right. So now we could say, well, okay, let's say it's greater than, say 5. We'll say yay. And else if, all right, $sign input is greater than, I don't know, 2. Greater than 2, semicolon, echo, boo. I don't know, whatever it is. Now if we run this again, I say 2, it says boo. If I run 3, it says boo. I say 5, it says yay. All right. Now something you have to be careful here. All right, I'm going to go modify this ever so slightly. All right. So an if-else if is saying, if this is true, do this. Otherwise, check to see if this is true. And if you could just keep having else ifs, it would say, checks the first one. If it's not true, then it checks the second. If it's not true, then it checks the third, blah, 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 blah. And you could have a catch-all here. You could do just an else. All right. And then we could echo none. All right. So if I made that 0, it says none. All right. So that is a little catch-all there. But what you have to be careful is if you would say if, and then you would end that if, then we do it again. All right, so it's now 2 completely separate if statements. Now when I run it, if I'm 5 is greater than 2, 5 is greater than 5, I'm going to get yay and boo. All right, because it's actually running both if statements. So it says, hey, is this true? And it says, yes. Okay, echo yay. And then it leaves that if statement and enters a new if statement. So it's like, oh, okay, I should run it again. Is this true? All right, so there is a slight difference between multiple if statements, all individual sections, and one if statement that has else ifs. All right, so you do need to be kind of careful about which one you're picking. Normally, you probably want to do the else ifs. If you only ever want one of those outputs to run, the else if is the one you want to pick. All right. Now you also do need to be careful when you're doing your else ifs, because if I put 2 here and 5 here, the 5 would never run, because anything greater than 2 is going to run yay, and then it's not even going to check this statement because it ran this one. So it runs the first one, so it's not checking the second one. So you do need to be kind of careful there with your else ifs, especially if you're doing like checking numbers or things, to make sure that you put them in an order that makes sense. All right. So just something to be kind of careful of. Skip case statements. All right. Anyway, we'll talk about it anyway. Do I have a case statement in here? I do. All right. So we can check my case statement. Now, what case statements are, it's basically a whole bunch of if statements. So it'll be a whole bunch of if, else if, else if, else if, else if, else if. All right. But the difference is you're only checking for one specific thing. So here I'm checking for the word one, O-N-E. Here I'm checking for the word two. All right. And that's all that's going on. So let's go ahead and run that just so you can see what it does. So sh case, it's again waiting for an input. So I'm going to type in 2, TWO, and it outputs 2. Probably not my best choice, but that's how I have it up. I type in 3, it doesn't do anything. Notice this is the word I typed in. It doesn't output anything because I don't have it set up to do anything. All right. So it is a very useful thing. All right. Now again, so here we have case input in. All right. So we're looking for the variable input in, and it's in these words right here. All right. So that's where we have echo, and then 2 semicolons, and ends that check statement, and it goes to the next one. So it ends that logic, goes to the next one. All right. If you want to have a catch-all, which is always good to have a catch-all, it's a asterisk and then a parenthesis. Remember asterisks from the previous lesson where it was that like basically anything goes? There's your asterisk for you. Showing up again. All right. So then we would echo. I'm going to put this. I don't understand. Right. So now if I do this and I type in something it doesn't know, it tells me I don't understand. All right. So that's what's going on there with case statements. So it works a lot like an if statement, but we're using the term case this time. And if you notice, it's case backwards to exit out of it. All right, moving on, we are up to things that have to do with looping. Right? So the first one that we're going to do is for loops. Right? So for is from one thing to other things inside a group. All right. So we've got, let's go ahead and get out of this. So I believe I have an for loop, a for in here. All right, here we go. So I've got servers equals, and so I'm saying variable servers equals 3 different things: server A, server B, server C. So each of those being a different word. All right. And then it says for S in servers do, and it says echo doing something to S. All right. So what this is doing, and I would tab this over. All right. Formatting your stuff is very helpful to make sure that you've got that when you're reading through it, you can understand what's going on. If you don't format it that way, if you just leave it back, it's perfectly fine. It knows that it does for does everything for do and done. All right. But for your benefit of you reading to know that this stuff is being looped, I suggest you tab it over. Same thing with if statements and case statements and things like that. I suggest formatting it with tabs or spaces at least, so you can see kind of this stuff are nested inside of other things. All right, so that's a personal statement there. But anyway, if we run through this, right? So if I do sh4, all right, and it says do something to server A, do something to server B, do something to server C. So basically just said, okay, for every item inside servers, we're going to repeat the same thing over and over again. All right, so it's going to do something so many times. All right. Now the other option that you could do here, and again for for, we're doing do and done. We're not using for backwards, which I find a little annoying, but that's the way it works. All right, and then for whiles, we're doing the same thing. Do and done again is going to be used again. So let me go ahead and do nano while. All right. So here you can see I set I equal to 0. Go ahead and tab these things over, again for my benefit. And I say for the variable I is less than 10, do something. So we're going to echo I, and then we're going to do I equals the $sign of I plus I 1. All right, so we're adding 1 to that value. All right. So when we run this, you should see it basically just count from 0 to 10, I believe it is. All right, so sh while. Here we go. Yep, 0, 1, 2, 3, 4, 5, 7, 8, 9. All right. And again, we could change that. You can make it, 20 or 40 or whatever you would want. There's an nano. There we go. For good benefit here, let's just go ahead and make this 40. All right. So if I would do my sh while again, there you go. Now we count from 0 to 39. All right. So in a nutshell, those are your scripting basics.